Alright, so this is the review for the test that we'll have tomorrow, and the majority of the test will be on those quadratics. So if we take a look at number 1, you were asked to solve the quadratic equation 6x squared plus 5x minus 6 equals 0. And the method you use is your choice. Alright, so I chose the factoring method. So what I'm going to do is I'm going to take the 6x squared plus the 5x minus 6, and I'm going to factor, basically like we did yesterday. We're going to have to use bottoms up here. So if I use bottoms up, this now becomes x squared plus 5x minus 36, because 6 times negative 6 is negative 36. Once we get to this point, we can factor that out. We know x times x is x squared. The question is, what two numbers can I multiply together to get negative 36, but would also add up to a positive 5? Anybody find those two numbers? 9 and negative 4. Let's try it out. 9 and negative 4. When you multiply them, they do give us a negative 36, and when we add them together, we also get a positive 5. So that is correct. Now, we don't stop there, though. Underneath that 9 and 4, we're going to divide it by a what? 6. It's the leading coefficient. 6 is the leading coefficient. So what we're going to have to do is reduce these fractions. 9 over 6 can be reduced to what? 9 over 6. What do you reduce that to? 3 over 2. 4 over 6 can also be reduced. That reduces to 2/3. Now remember, we're using bottoms up here. And in bottoms up, we can't have fractions. We're going to move the bottom number up in front of the x. So this x plus 3/2 now becomes 2x plus 3. Same thing on the other. The 3 is going to come up in front of the x, making it 3x minus 2. So these are going to be my factors of this quadratic. But we're not done because we're looking for the solution. So what we're going to do is we're going to take these factors and we're going to set each one of them equal to 0 and solve. So there's the first one set equal to 0. And here's the second one equal to 0. So let's solve these two equations. Subtract 3. Divide by 2. And one of my solutions is negative 3/2. That's one of the solutions. The other solution, we're going to come over here and find it. We're going to add 2. And then we're going to divide by 3. Which means the other solution is going to be a 2/3. So the two solutions we end up with were negative 3/2 and 2/3. Does anybody notice anything about the solutions I just got? What's that? Yeah, they're the opposites of these factors that I had right here. Notice we had a positive 3/2, which means my solution is negative 3/2. Over here we had negative 2/3 in the factor, and my solution was positive 2/3. So that really have to go through there and do this part? No. Yes, ma'am? Yes. All right, so again, these are the two solutions we're looking for. Have fun with the test. Could we have gotten that using quadratic formula? Sure. All right, let's go on to number 2. Number 2, you were asked to find the discriminant and describe the root. Now, you didn't have to solve the whole thing, guys. All you had to do was find the discriminant, meaning you only had to use this part right here of the quadratic formula, b squared minus 4ac. Let's not forget a is the number in front of the x squared, b is the number in front of the x, and c is our constant. So all I'm going to do is replace a, b, and c with those three numbers. So we should have, let's see, 10 squared minus 4 times 6 times 1. Okay, so if we put that in the calculator, what do we end up with? What was the number? 76. So the question is 76. If we come over here and look at the board, 76 is obviously a positive number. The question is it a perfect square or not a perfect square? 76, is it a perfect square? No. Therefore, we should have two irrational roots. Two irrational roots. Now make sure on the test tomorrow you have both of these. If all you do is put 76 and you don't put the two irrational roots, it will be counted wrong. Make sure you answer both parts of the question. Okay, going on to number 3. Write a quadratic equation that has the roots negative 4 and positive 2. So they gave us a solution. We got to find the equation that goes with those solutions. Well, since they gave us the roots, Then we should also know that the factors are the opposite, meaning we should have x plus 4 as one of our factors, and we should have x minus 2 as the other factor. And if we know the factors, we should come up with the quadratic using some FOIL method here. So that's what I'm going to do next. Is some FOIL. X times x is going to give me x squared. X times negative 2 is negative 2x. 4 times x is 4x. And 4 times negative 2 is negative 8. If I simplify that, I end up with x squared. Negative 2x plus 4x gives us a 2x. And of course, I still got my minus 8. So the quadratic here is x squared plus 2x minus 8. Now, if you put that on the test, it will be counted wrong. Why? Well, it is standard form. Why is it wrong? That's right, because it's not equal to 0. I asked you to write a quadratic equation. The key word here being equation. And in order to have an equation, you've got to have it equal to something. In this case, it's got to be equal to a 0. So if you leave off the equal 0 part, yes, it is going to be counted wrong. So be careful. So that's what I'm looking for on number 3. Number 4 is just like number 2. We're looking for the discriminant and what is the nature of those roots. Before I answer that question, I want to make sure this is equal to 0 first. So I'm going to move the 4x and the 13 over to the left-hand side. Now I'm ready to start looking for that discriminant, which is b squared minus 4ac. Our b is negative 4, a is 2, and c is 13. So if I put that in the calculator, what number do we get? What do we get? You didn't do this one? And so what did you get? Negative 88. Just a reminder for you guys, don't forget when you're putting that in your calculator, make sure you have negative 4 in parentheses. So negative 88 is our discriminant. Now that we know what our discriminant is, if we look over here on the board, the question is, what kind of root are we going to have? Well, since negative 88 is less than 0, we should have 2 complex roots. So make sure you have that over here. 2 complex roots. Again, you must have both parts in order to get credit for this question, not just the number. Number 5. The path of a toy rocket launched from an observation tower is modeled by the equation h of t is equal to negative 16t squared plus 48t plus 64, where t is going to represent the time in seconds, and h is going to be the height in feet. What we're looking for is how many seconds will it take for the rocket to reach 85 feet? Well, 85 feet is the height. So we're going to replace h of t over here with 85. And it's going to be equal to negative 16t squared plus 48t plus 64. So this is what I'm working with. This is what I'm solving. This is a quadratic. Well, the first thing is, when you're working with quadratics, it's got to be equal to 0. So the first thing I'm going to do is make this thing equal to 0. So I'm going to subtract the 85. And notice I'm subtracting that 85 from the 64. They got to be like terms in order to subtract. So I still got my negative 16t squared. Still got my 48t. I've got 64 minus 81, or 85. 64 minus 85 was negative 21. So here's my new quadratic. That quadratic is what I need to solve. I need to solve for t. T represents the time in seconds. Now notice here it says how many seconds will the toy reach its first time at 85 feet. Why is it going to reach twice at 85 feet? Yeah, because it's going up, it reaches 85 feet, but on the way down, it also reaches 85 feet. So we're looking for the first one. So we need to solve this quadratic. I think the method we'll use on this one is the graphing method. So everybody go to your calculator, and let's go ahead and graph this thing real quick. Go to y equals, and let's graph negative 16 t squared plus 48t minus 21. Graphic form. What we're going to be looking for are the solutions, and the solutions are the x-intercepts, which in our case, we're going to have 2 of those, 2 x-intercepts. We only need to find the first one. That's the only one we're concerned with. We don't need to worry about the second. So I'm going to sketch what you guys are looking at on your calculator. Let me borrow somebody's calculator. What you got? All right, so this is what we're looking at on your calculator. Looks something like this right here. What we're looking for is the first X-intercept. We're looking for this one right here. That is one of the solutions. Now you'll notice it doesn't fall exactly on the 1. Actually, it falls somewhere between the 0 and the 1. We need to find exactly where it's at. So we're going to use a feature on the calculator. And to find that feature, you're going to have to go to second trace. Go to second trace. And what we need to do is tell the calculator to find that X-intercept for us. So which one are we going to use in second trace? Do we have one that says X-intercept? No, we're going to have to use the one that says 0. Because remember, X-intercept is the same thing as 0. So select number 2, 0. When you do that, it's going to ask you a couple of questions before it finds that point. First thing it's going to do is ask you to move to the left of your 0. So make sure you're somewhere in that area. Once you're somewhere in that area, you're going to hit enter. Then it's going to ask you to move to the right of that X-intercept. So move your cursor somewhere in this area here. Hit enter. Then it's going to ask you to guess. So they want you to get the cursor as close to that X-intercept as possible. Once you get as close as you can, hit enter. And you're going to see one of the solutions down there at the bottom. So decimal. What is that decimal? Point something. What is it? 0.5, 3, 1, 7, 5, something, 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 right? So the more decimals we have, the more accurate we're going to be. It says, in how many seconds does it reach its first time at 85 feet? You're looking at it right here. 0.53175, so on, so on, so on. Right? Now, is that the only way to come up with that number there? No. I'm sure some of you guys went about it a little bit differently, but we should all end up with that same decimal, 0.53175, and so on. Anybody get that same answer but did it differently? Eric, you did it differently? Did you come up with the same answer, same number? 174? Okay, look. Okay, okay, so then you would have actually done the second, right? Is that what the second one was? Did you say 1 point something, right?
No, it's the same thing as I did.
Oh, okay. Oh, okay. This right here was a 4. Okay. Close enough. Close enough. All right, so that was number 5. Number 6, this should have been fairly easy. All we're looking for on number 6 is the vertex. The vertex is either the minimum or the maximum point. In this particular case, it's the maximum. This right here is the vertex. The question is, what is the ordered pair for that vertex? 4, -2. So the answer I'm looking for on number 6 is 4, -2. Number 7, the function y equals -64 times x minus 3 squared plus 350 models the store's profit in dollars on a certain food item, where x is the price of that item. They want to know what should the store charge for the item to maximize its profit. What is the maximum profit they could earn according to this model? So there's 2 parts of this answer. We want to know what should they charge and what kind of profit are they going to make if they charge that. Well, in order to find that maximum, keyword here, is we're going to have to find the vertex of this quadratic. Now, I don't know if you noticed this, but this particular quadratic is written in this form right here. Anybody remember what that form was called? Y equals a times x minus 8 squared plus k. All right, so what's that form called? Starts with a V. E. What? Come on, guys. Vertex form. This is called the vertex form. You might want to write that down. That's going to show up on the test. If you don't remember that, write it down. Vertex form. Anybody know why they call this the vertex form? Yeah, because the H and the K represent the vertex. And if that's the case, we know exactly what the vertex is In this equation right here, the vertex is 350. Notice the h is the opposite, so it's not -3, but +3. That is our vertex. It's our maximum. Now, why is that important for us? Well, what did it say x represented? It's the price of the item. What is the 350 representing? It's the profit. So we got both of our answers sitting right here in front of us. What should the store charge? They should be charging $3. Why? Why should they charge $3? Because if they do that, they're going to make their maximum profit, and that profit is going to be $350. That's their profit they're going to earn if they sell it for $3. So again, two parts of that answer, or two parts of that question. $3 is the answer to the first part. $350 is the answer to the second part. Okay, going on. Number 8. Greg is looking at the graph of a problem. His vertex is at -0.5 and -4.5. It intersects the x-axis at -2 and at 1. It also intersects the y-axis at -4. What are the roots to this quadratic? Please correct. What? -2 and +1. Remember, the roots and the x-intercepts are the same thing. So when they say what are the roots, they're also asking you what are the x-intercepts. Okay, number 9. 0 equals 2x squared minus 4x minus 3. We're going to solve that to the nearest hundred. So we are going to get a decimal for this one. Again, the method you use is your choice. I think to speed things up, we're going to use the graphing method here. All right, so everybody go to your calculator. We got lucky on this one. It's already equal to 0. All we're going to do is graph it and find its x-intercepts. All right, so graph 2x squared plus minus 4x minus 3. Let's graph it. Looks like your graph is looking something like this right here. What we're looking for are the solutions. We're looking for the x-intercepts. We got one here, and we got another one over here. Let's find the first one over here on the left-hand side. Let's go to our second trace again, like we did earlier. Second trace. We're going to find the 0, which is the same thing as x-intercepts. Just like earlier, they're going to ask us to move to the left of the x-intercept, so make sure your cursor is somewhere in this area. Then they're going to ask you to move to the right, so move somewhere in this area right here. Then they're going to ask you to guess, so put your cursor as close to that x-intercept as possible. And then hit enter. And you're going to get a decimal. Question is, what is that decimal to the nearest hundreds? We're rounding this to the hundredths place. So what is that decimal? Negative what? 0.58. That would be the decimal to the nearest hundred. So we just found one of the solutions. Let's find the other solution doing it the same way. We're going to go to that second trace again, and we're going to ask it to find the other 0. Now remember, it's going to ask you to move to the left, so this would be the left of the second x-intercept. Then it's going to ask you to move to the right, so this would be to the right of that x-intercept. Then it's going to ask you to guess, so you would put your cursor as close to that x-intercept as possible. And once again, it's going to give you another decimal. Question is, what is that decimal to the nearest hundreds? 2.58. So these are the two solutions to the nearest hundreds. All right, that's number 9. Number 10. Marcus is building a rectangular pen for animals using the side of a barn for one side. He has 200 feet of fencing to use for the other 3 sides. What should the dimensions be to maximize the area of the pen? All right, so he's got his barn. Here's the barn. And right next to that barn, he's going to put a fence. So here's the fence. Notice it does say that it's a rectangular shape. Now what we know is he has 200 feet of fencing. We want to know what should his dimensions be so that we have the most area. Okay. How do you find area of a rectangle? Length times width. Right now I don't know the length and the width. Okay, so what I'm going to do is I'm going to call the width x. Now of course we're dealing with a rectangle here, so if this is x, then this is going to be x. So if this is x and this is x, what should that side be? How many feet of fencing do we have to work with? How much? 200. So if we have 200 feet of fencing, and we're using some of the fencing here and some of the fencing here, what should this one be? What? 200 minus 2x. Okay, so whatever we have left over from these two sides is what we're going to use over here. So that would be 200 minus these 2x's that we're using over there. All right, so that's what we're working with so far. Now, like you guys said earlier, to find the area, you need to multiply length times the width. So what I'm going to do is I'm going to take x, which is the width, and multiply it times the length, which is this right here. And what that's going to do is give me the area, and I'm going to call the area y. So I'm going to use a little distributive property here. This is going to be 200x minus 2x squared equals y. So this is the quadratic we're working. What we're looking for are the dimensions. What should the dimensions be so that we maximize the area of the pin? Maximize. Keyword. Maximum. Maximum. Vertex. We want to know what's the vertex. Because if we know the vertex, we know what kind of area we're working with, and we also, that'll help us find the dimensions as well. So how do I find the vertex given this equation right here? Come on, guys, wake up. 200x minus 2x squared. How do I find the vertex? You can put it in the calculator. That would be one way. So put it in your calculator and find me the vertex at. I want to know what the vertex is. I can tell you're going to run into a problem if you try and graph this. What's the problem you're going to run into? The graph is really big, and if you're looking for the vertex, you're going to have to play around with your window until you can find that vertex. Well, you could do that, but you might waste a lot of time on the test, leaving you less time on other questions. There is a faster way to find the vertex. Anybody remember? This was on our notes. We can also find the vertex if it's in standard form using this thing right here. Negative b divided by 2a would give us our x value. And then we can take that x value, plug it in, and find the y value. So I think we're going to go that route to speed things up. Otherwise, we're going to have to sit here a while and play with the window. All right, so what I'm going to do is replace b with what number? Be careful. Let me fix this before you answer that. Notice I switched those so that it would be in the standard form. All right, let's try that again. What is b? 200. A is a negative 2. And 2 times a negative 2 would make this a negative 4. And a negative 200 divided by negative 4 would result in a what? Positive 50. So we know what the x value is. We know it's 50. Well, since I'm looking for the dimensions, that's really all I need, because we just found out what the width is. We just found out that the width should be 50. What should the length be then? Well, if I put that 50 right here, 200 minus 2 times 50, what are we going to end up with? 100. So what should the dimensions be? The dimension should be 50 by 100. And if I do that 50 by 100, what's the area of that thing going to be? What? 5,000. 5,000 would be the area of this particular pen. And I got that multiplying 50 times 100. All right, that's number 10. Let's go to number 11. We're almost there. Number 11, how does the graph of y equals negative 1/2 x squared compare to the graph of y equals x squared? Well, let's find out. Let's put it in our calculator and graph both of these and take a look. How does y equals negative 1/2 x squared compare with y equals x squared, which happens to be our parent function? There's two things I'm looking for. Two things. What's one of them? Reflection. That's one of them. We have a reflection over the x-axis. What's the other thing you notice? It's vertically compressed, which is making it wider. Right? The 1/2 is making it wider because we are compressing it vertically. So those are the two things that I'm looking for on number 11. Number 12, this is the one we changed. When asked to solve the inequality 0 is greater than x squared plus 3x minus 10, Kevin thought about its graph and responded that x could be any real number. Was he correct? Why or why not? All right, so we've got this inequality that we need to work with, and he's saying that it could be any real number. Is that true? Well, here's what we did when it came to inequalities. First, we need to find the solutions to the quadratic, and we can use the method of our choice. I think I'm going to use factoring here. X times x is going to give me the x squared. What two numbers can I multiply together to get negative 10, but would also add up to a positive 3? That would be what? Positive, what? 5 and negative 2. They add up to 3, and when I multiply them, they give me the negative 10. So these are the factors. And if those are the factors, the solutions to this quadratic would be negative 5 and positive 2. So those are the solutions. What we did was, with those solutions, we put them on the number line. I don't know if you remember this. Negative 5 is the smallest number, so it goes over here on the left. 2 is the larger number, it goes on the right. We're going to use open circles on those. Now keep in mind, you may have to use closed circles. How do you know when to use a closed circle? Yeah, if it has an equal sign on the inequality. This one doesn't, so we're using open circles. What we did, and I'm going to try and speed it up here because we're running out of time, is what we did is we took 3 numbers. We took a number from each of these 3 sections, and we tested it out to see whether we ended up with a true or a false statement. Now, to save time, I'm just going to pick a number here in the middle. And a number in the middle between negative 5 and 2 would be 0. So if I put a 0 in for my x's, if I put a 0 in for my x's, do I get a true or a false statement? Well, let's find out. 0 squared plus 3 times 0 minus 10. What do you get when you put that in your calculator? Negative 10. Is 0 greater than negative 10? Yes, that is a true statement. And because it's a true statement, our solutions are in here. Now keep in mind, if I would have taken a test point here, I would have got false, false in this area, which is why it's not part of the solution. The only part of the solutions are numbers between negative 5 and positive 2. So when he says it can be any real number, is that correct? No, that is not correct. Why? Because our solutions are only between negative 5 and positive 2. That's where the solutions are. Okay, so make sure you either have the graph or write that down. It's number 12. All right, let's try and get one more done here. Find the vertex of this function here. We can do this a couple of different ways. I think the fastest way is to graph it. graph it, and find the vertex. All right, guys, we'll go ahead and stop there. Test tomorrow. Test tomorrow.